Let's review some key problems in our radical chapter. First off, we're simplifying a cube root, which means I need to find cubes inside of this radical. Negative 24 can be broken down into negative 8 times 3, and negative 8 is a perfect cube. It's the perfect cube of negative 2. So that tells me I will have a negative 2 outside of my radical in my answer, and that I will have a 3 left inside my cube root. For each of these variables, I'm going to take the exponents and divide by 3. 5 divided by 3 is 1 remainder 2. 7 divided by 3 is 2 remainder 1. And 9 divided by 3 is 3 with no remainder. That will help me to simplify my answer. For x's, I will have one x on the outside and an x squared on the inside. For y's, I will have a y squared outside the radical with one y left inside. And for the z's, I will have z cubed on the outside. And that would be the simplified form of the answer. For negative exponents, we know that we've got to move things down to the denominator. So we have 1 over 16 to the 1/4. Now that 1/4 root power tells us we have the 1/4 root, and we have the 4th root of 16, which is equal to 2. So this simplifies to 1/2. Rational exponents is another way of saying fractional exponents. This can be rewritten as x to the 3/4. The numerator represents the power, the denominator represents the type of root. When adding radicals, I need to first make sure they're all the same type of radical with the same index. All these are cube roots, and I need to make sure that I have the same radicand or stuff inside. We need to simplify each of these. This 16 here is an 8 times 2, and this 54 is a 27 times 2. Now, when I cube root the 8, I get 2 coming out, so I will have a 2 on the outside with a 2 left inside. X squared cannot come out of a cube root, so I already have an x outside. I now have the cube root of my leftover 2 times x squared. For this next one, I've got a 5 of a kind with the x's, and I need to take 3 of those out. So I'm going to keep my minus 4 outside, bring 1 x out, and inside of the cube root I will still have the 2 and the remaining 2 x's that are there. The cube root of 27 is 3, which comes out, multiplies with the 5, and gives me 15, times the x that's already out front, times again the cube root of 2x squared. Now that we have 3 things adding together, all of which have the same radicand, we can just combine the coefficients. 2 minus 4 is negative 2, plus that 15 gives me 13x times the cube root of 2x squared. We know that we're not allowed to have a radical in the denominator, so in this case, because it's a square root, we're going to multiply by the square root of 3w over the square root of 3w. Our numerator is going to become the square root of 15w, and the denominator is the square root of 9w squared, which simplifies into 3w in the denominator. So we have the square root of 15w over 3w. When we have a cube root in the denominator, we have to get creative with what we multiply by in order to create 3 of a kinds. I already have 1 2 inside the radical, so I need 2 more 2's to create a 3 of a kind. I've already got 2 x's, so I need 1 more x inside to create a 3 of a kind. Now I'm going to be multiplying by cube root of 4x over cube root of 4x. I just multiply the 2 2's together this way. My numerator now becomes negative 2 times the cube root of 4x divided by the cube root of 8x cubed. Now all of that is a perfect cube of 2x. So I've got negative 2 cube root of 4x over this 2x, and I can cancel those factors of 2 in the numerator and denominator and rewrite this as negative the cube root of 4x all over x.